So, thanks for the introduction. My name is Nebeling, and this is Katy Madier. And Katy decided not to go to her own graduation. Instead, she decided to go for Kai. And so, therefore, we're going to co-present this paper. It's our work on 360proto. And I'll get us started, and then Katy's going to take over in a few minutes. So, last year at Kai, I worked on a project called Proto AR. I'll show you a quick summary here. The idea was to start prototyping mobile AR applications on paper and then provide a set of tools to designers so that they can quickly capture paper and also Play-Doh as placeholders for 3D models and that way rapidly generate mobile AR applications. At that stage, they were marker-based. And so this year, we're going to present 360proto, and it is the next tool in my line. I strongly believe, like Hiroshi Ishii, who fights the pixel empire, I fight the Unity empire. I strongly believe that we need new tools to support AR/VR prototyping. And I'm really impressed by the power and flexibility that we have with lo-fi prototyping, in particular paper prototyping. Now, if you teach interaction design like I do, I often refer to Mark Rettig's paper on prototyping for tiny fingers, and this is the illustration that was used there to illustrate how a paper prototype could be tested. And so we expand this vision to 360 paper prototyping, modernized a little bit to support both prototyping with VR users and AR users in a similar fashion. So this project presents, or this paper, the main contribution, the way I see it is the system that we produced here, which consists of a suite of tools. That's how I think of 360proto, for generating interactive AR/VR prototypes from paper. So both the interactive part and that we generate something from paper is key here. And so the paper actually contributes a study on the use of emerging paper templates in the practitioner community, specifically for AR/VR. We developed 3 novel tools in 360proto that we're going to demonstrate here as well. And we show support for Wizard of Oz prototyping, where we simulate rather than implement everything to produce an AR/VR interface. And so I'd like to hand over to my colleague, Katy.
So initially, we gathered design templates from practitioners from places like Facebook and Medium, and here, as shown in this slide, we found a variety of templates for designing environments for controllers and faces for AR/VR experiences. And initially, we conducted a set of design jams with 36 master's students to capture information for requirements to better understand how users prototype for AR and VR. The students completed specific design challenges by recreating 3 interactions from existing and imagined applications using plain paper and an equirectangular environment template. During the first design jams, we also tested our initial prototype for our tool. And so with these design jams, we uncovered 3 requirements for the tool. The first is the support for layered prototypes. So we found that designers needed to prototype all the parts of the AR/VR app, from the AR marker overlays to the VR controller menus and HUDs. So our tool needed to be able to support multiple design layers. And the second requirement we found was an integration with digital tools. So AR/VR prototypes require a big jump from traditional paper prototyping, which is just 2D. Students found it was difficult to imagine what a design may look like once it was AR or VR. So we found that our tool should incorporate realistic previews of the designs on an AR or VR device. And our third requirement is for Wizard of Oz capabilities. So in the design jams, designers mentioned that it was great to show the interactivity on paper. And so we want to be able to provide that dynamic real-time preview of interaction within the tool. And so we derived our inspiration for this tool from 360 photos in their equirectangular format. So we were able to find to gather information and create a 360 paper template based off of a VR grid created by design practitioners. And as shown in this image, the equirectangular grid can be morphed into a sphere to create the VR environment. And to explain our 360 paper template, imagine that you can wrap this grid around your head to form a circle. And so you can see that the very center of the grid is where you would put content that is directly in front of you. And at the top, you would put content that is directly above you. And at the edges, you would show content that's behind you. And based on our initial feedback from design jams, we added a field of view and a range of motion based on the work of Mike Alger and other design practitioners. These additions were made to help designers be able to draw within scale and understand object movement that happens in front of the viewer. So to test our requirements, we created this example of a mountain view with butterflies. This example is composed of 3 spherical layers, a background, a midground, and a foreground, and each is hand-drawn on a 360 paper template. These layers are then placed at different distances from the user to simulate depth within the scene. And so here, Michael will be able to provide information about the 360 Paper Studio.
All right. Thanks, Katy. 360 Proto Studio. I was hoping to give a live demo, but we rely on Wi-Fi, and this room is particularly bad for Wi-Fi. So what I'll do instead is I have lots of videos, and I hope to convey how this works. So the way this tool works, if it works, the way this presentation works. Hang on. I didn't get any of this. All right. So the labels that I show here, it's actually a fairly complex tool. What I want to illustrate with this, if you look at we actually simulate what this would look like on a mobile phone, and that mobile phone could be like in a cardboard or in a Daydream, but you see that view here. And what I also illustrate here is on the right, where it says 360 layers, is actually how we composed this environment from the different 360 layers, from background to foreground to midground. And we have various features in the tool, including chroma keying features to remove background from like paper background and other kinds of features that you want to remove. And we have a live feed that means we can actually stream back to an AR or VR user, which is a capability that we use for Wizard of Oz. So what I want you to understand a little bit the different components of this tool. So one part of 360 Proto actually runs on a mobile phone. We developed our own camera app, if you will, that has a variety of features. It's also multi-user, and it can actually be used in a classroom environment. And I've conducted initial usage of the tool in my own AR/VR course. On this app, you can actually capture the paper template that Katy was talking about. And so this would be in a 3-step approach. The camera itself, so the 360 Proto camera tool, has the initial support for capturing the environment from paper and providing a preview in cardboard. So the way this looks is, for example, if you have a forest scene here composed, not sketched, but composed using paper printouts and cutouts, you would take, I'm sorry, this is a bit weird. Okay, you would take a picture and you would immediately see a preview, and I'm going to show you a video where this actually then happens live. Okay. So what just happened is I took a picture, and so this video wasn't edited. It is immediate preview on a smartphone and stereoscopic rendering on cardboard. Sorry about the technology hiccups here. All right, so the next step is actually putting this tool in the larger workflow. So this was just what's happening on a mobile phone, which allows rapid previewing in VR or in 360 with a handheld, so just like using the magic mirror mode. But then we have a more sophisticated part, which is the studio, and the studio is usually run on a laptop. So that's the second step, where you can compose multiple layers that you may have captured. And I want to show you one that I think very powerful feature is there is a third component to this project, is the final AR or VR application that would support things like a moving butterfly. So I want to illustrate you one of the examples that we created that I'm particularly proud of. It is possible with this tool to create a live preview of a butterfly essentially flying in front of the user. We do this in AR, and this is really something I would have liked to live demonstrate here. It is possible to spawn a 360 sphere around me and project a butterfly right in front of me if I walk around with my mobile phone. You'll see a video of this in a second. The way we do this is I actually, on top of the paper prototyping template, we use a marker to move the digital butterfly. And then I'll show you in the second part of this video is when this butterfly is then actually not live animated, but it's actually kind of in the room in AR, it's spatially anchored. So the first part is here our live streaming, including capturing. And it's really difficult to, because the other user would receive this live stream. So it's really difficult to illustrate on stage how this would feel. But so we capture, and now we're moving over to the end user who sees the butterfly is basically appearing live in the room. All right. So if you're interested in this is web-based, and so it works in a variety of setups. We have the camera tool. We have the studio that actually supports all the different layers. And we have the app that is running on, again, a smartphone. And then we stream WebRTC media streams into various directions to actually capture from paper and then live stream and compose AR/VR interfaces. One feature that I'm particularly proud of is because current mobile phones are still, they overheat. When you run this AR for 20 minutes, they overheat and they actually, go down in terms of performance. So we had to pay a lot of attention to where we actually compose the AR experience. So we capture the live video in the app, we stream it to the studio. The studio does the AR composition based on information from the mobile phone and streams it back to the mobile phone, and that seemed to be the most performant way to do this. So I'll show you one of the examples that Katy has worked on. Katy is a designer, and I wanted Katy to create the Star Trek for me, the next generation Star Trek. And I want to illustrate a little bit how we do this. So what I'm doing here is we just landed in my house. We are Star Trek. I'm Captain Picard, and I'm going into my, we just landed in my house, so now we're looking at my kitchen / dining room. And then fast forward, we're walking into space right now, and I'm showing you what this Star Trek looks from the outside. And you also see our screen, which looks into my living room. So what I just illustrated here is actually a very flexible use of the tool. We are constructing this experience. If you're familiar with the Star Trek, the captain's chair in the middle is essentially a smaller 360 sphere. There's another layer around it, which is essentially the bridge. And then we have the observation deck. That is a room that is just next to the bridge. And we built this by oversecting the spheres on the right. And using AR Core, it is then possible to essentially walk inside your paper prototype. So we explored the use of 360proto. We ourselves tried to create a variety of experiences. We asked students to recreate relatively complex AR/VR projects they had previously created with A-Frame and Unity. We asked students in a design jam to create multi-layer 360 prototypes. We really wanted to explore how complex can it get. And we also explored live streaming and Wizard of Oz capabilities. So we have a variety of results, and basically here are some of the things that you can do with this template. In a 3-hour class we actually ran with my AR/VR course. We had students work individually, and we just show you a sample here. So using the template, they could quickly prototype a VR YouTube experience, including the menu. There are specific templates for VR controllers, as you can see on the right. And then an AR news interface with with news content appearing in front of the user. Or also, if you are more interested in facial-based AR, this is also supported by our tool. We have a variety of features of that. So I'm going to show you 2 more examples that I think are interesting, and then we're going to wrap up. So if you know the Amazon AR live shopping view, that I'm sure the Amazon team spent some resources on it, prototyping, we can create that. We can also recreate a highly interactive racquetball game. This is one of Katy's and my own favorite example. In this case, Katy was the racket player in VR, and I was the tennis ball on a toothpick above the paper template. What did we learn from trying this together with students and our own experiences? So the overall feedback that we received, apart from the fact, I guess one of the key things, you do not have to implement anything. You do not have to be a programmer. You do not have to know any APIs, which is, the state of the art is you just have to know Unity, or you do native AR Core ARKit or HoloLens mixed reality toolkit. So, but our students who are increasingly interested in UX find the tools useful for design space exploration. So this is a powerful tool to quickly eliminate AR as an option. You do not have to implement all the things to realize that AR is not the right approach. You can just prototype this very quickly. The templates guide design, but sketching is actually still difficult. Katy spent several weeks really exploring the template and optimizing the template. And so that way we could create the Star Trek, for example. For our students in particular, but I think also Katy, when she worked on it, was difficult to imagine the final user experience. So the live streaming support is very important, that you can actually try it out. So essentially we need all three tools in 360proto to really prototype an AR/VR experience. The tools did facilitate creation of realistic AR/VR interfaces. The fact that they are lo-fi and paper was actually never really mentioned as like a negative. It was sufficient to experience at least, and we think this is actually the way to go. This is the lo-fi prototyping version of AR and VR. And the Wizard of Oz actually enabled a lot of these interactive experiences, and our students actually stated that they consider the AR/VR prototypes created with 360proto as medium fidelity, because obviously high fidelity would then be probably that thing in Unity again. So again, we're not trying to replace Unity, we're just trying to fill the workflow in AR/VR so that we can have a nice prototyping workflow starting with low fidelity prototyping. And that is actually the paper, 360proto. Thanks for your attention.
Thank you. Any questions?
Michael, you had reasons for going with lo-fi in almost everything, you know, with the phones and everything. It's a very inexpensive operation. Are you any plans for working with Unreal Engine or something like that and raise the equipment and not doing it at the web-based model?
So we chose A-frame for a variety of reasons. That way I can actually run it in the class, and it works relatively okay. I mean, your question actually targets multiple aspects. So my attempt is not to create. I don't think I want to be more higher fidelity than this. I think this is fine. The next step is actually going into Unity, or actually just stopping that project, which is you just saved thousands of dollars asking a developer to create that prototype for you, and then realize it's not the right thing. And I think the way I think about all these different prototyping tools, I put A-frame here, I put Unity here, and I put Unreal. I'm not tall enough, but higher than that. And Cinema 4D, I don't know where to put it. But the other thing is that this is actually a tool in this emerging space of lots of digital prototyping tools. It just really, we target the lo-fi prototyping gap, and I think that's just where I want to be. But there are transitions actually in hopefully upcoming work in the future that these prototyping tools, one of the limitations is the prototype dies with the tool, because we do not actually generate code. We do not actually produce anything. We could export assets to A-frame. But that's something that I'm increasingly exploring, this bridge into tools like A-frame or Unity, but not replace them.
Hello, Long Pan here from National Taiwan University. Yeah, it's really interesting work. I really like it. I especially like the final part, the final video that you use the toothpick to animate the ball in the virtual world. But I'm particularly wondering, is it possible that the facilitator, the operators actually see the VR scene or the AR scene? How does the facilitator actually know what the user is looking at?
So that's actually a very good question. So we have the support to stream these streams and replicate those streams. It's a multi-streaming interface. In our experience, most of the time, we oriented ourselves using the studio that I showed you that actually has the live preview. That, well, it would be hard to find that slide right now. The tool that's running on the laptop has a live preview of what's happening for the phone user, and that is the orientation point for the wizard. So the wizard is just using that. However, we could replicate that stream and actually build other interesting tools by using this multi-streaming solution as well.
Okay.
So congratulations, this looks really interesting and fun to use. I wonder, you already mentioned there must be a difficulty to draw on the template and to predict what kind of distortion you need to draw the distortion on the paper, and if you have any thoughts on how to make this easier.
Yes, so in the process of drawing on this, if you understand anything about perspective, it might be good to forget about that, because it's really difficult to conventionally provide perspective in something like that curves so much at the poles. The way that I found to be easiest is to have that preview of what it will look like once it's been wrapped in a sphere. So using the tool, like while drawing, taking quick snapshots of the experience just to make sure that you're thinking in the right way about perspective was the way that I found to help most in practice.
Great. Thank you, everyone. Thank you, Michael and Katy. And thanks to all the speakers. They will be here for any questions that you might have.